So in this problem, we should identify the A, B's, and C's. Right as above. Our A value is what? What does that tell us? So our amplitude is 1. Raise your hand if you got that. The B value is also 1. How do I use B value? So that means our graph is going to finish over 2 pi. Phase shift. Our C value, notice how I'm not circling the minus sign, is pi over 6. Plus, what direction are you going there?
Right.
Right, 6 is correct. Remember my silly phrase, add to x, go west? There's no adding there, so you're going the other direction. Right, pi over 6. Okay, so that was step number 1, finding your period. Now here's the new part. You're going to put it between 0 and 2 pi. Everything in here, you're going to put. So x minus pi over 6. And here, you're just going to solve the inequality. So I'm going to add pi over 6 to all the columns. Now at this time it might be wise for you to change these into denominators of 6. 2 pi is 2 pi over 1. And I'm going to multiply that by what?
6. So 12 over
6 over 6, which gives me what?
12 pi over 6.
So now I can just do 12 plus 1 gives me what?
13 pi over 6.
13 pi over 6. So my graph is going to start here, end here, and it'll do that in a period of 2 pi. Let's draw a graph. Now, because I have a phase shift to the right, your points are actually to the right. We're going to count to 5 together. Ready, set, go.
1, 2, 3, 4, 5.
So this represents pi over 6. And this one over here represents 13 pi over 6. Now, if you get stuck on this, just draw a graph, evenly spaced, 5 points, and then you can input your y-axis later. So right now I'm doing the 4 intervals. My intervals are 1, 2, 3, and 4. Alright, let's see if we get lucky. Because I have a denominator 6, I can add the fractions. 1 plus 13 is?
14.
And half of 14 is?
7.
7 pi over 6. See if we get lucky again. We're basically just finding the midpoint. 1 plus 7.
8.
And 8 divided by 2.
1.
So this is 4 pi over 6, which reduces to what?
2 pi over 3.
2 pi over 3. So again, I'm just finding an average. 1 plus 7, and then dividing by 2, and then reducing. Do you see a pattern? 1, 4, 7, something, 13?
Yeah.
What am I counting by?
3.
1, 4, 7,
10.
10 pi over 6. And that reduces to
5 pi over 3.
5 pi over 3. Alright, we found our period, amplitude, period, and phase shift. We found our 5 points. We just found our 4 intervals, and now we're going to get our 5 x values. 5 x values come from the x axis. So I have x equals pi over 6. 2 pi over 3, 7 pi over 6, 5 pi over 3, and 13 pi over 6. Now if you think about what we've just done, my phase shift is to the right pi over 6. You see that? I'm pushing it off pi over 6. No long before, our graph used to come from the origin, but now it's pushed off by that amount. So if I do x minus pi over 6, and I take my x value, which is pi over 6, pi over 6 minus pi over 6 gives us 0. 2 pi over 3, which is 4 pi over 6. 4 minus 1 is,
3 pi over 6.
and 3 pi over 6 is
Pi over 3.
pi over 2.
2.
And if you keep doing that, you're basically going to get the quadrantals. Everyone say always quadrantals.
Always quadrant.
You're always going to get these. That's how you know you're doing it right based on the method I'm teaching you guys. 13 minus 1 gives you 12 pi over 6. 12 pi over 6 is 2 pi. Okay, now I'm going to take the sign of that value. Cross with sign at 0.
1,
0. Sign at pi over 2. Sign at pi.
2, -1, 0.
So I'm going to graph it. I have an amplitude of 1. Graph it. So now I have 0 at pi over 6, 1, 0 at pi, or 0 at 7 pi over 6, sorry, -1, and 13 pi over 6 is 0. Do you see what happened to the graph? It's essentially just pushed off by pi over 6.